The observable universe refers to the portion of the cosmos that we are capable of observing and studying using telescopes and other scientific instruments. However, this observational capability is inherently limited due to the finite speed at which light travels. Since light is our primary source of information about the universe, we can only detect objects and events that are within a certain distance from us. Consequently, we are unable to directly observe occurrences or celestial bodies that took place or formed very early in the universe's history, billions of years ago. Currently, scientists estimate that the diameter of the observable universe is approximately 93 billion light-years. This measurement is surprisingly vast when compared to the estimated age of the universe, which is about 13.8 billion years. The reason for this apparent discrepancy lies in the continuous expansion of the universe. Over time, cosmic expansion has caused objects that were once relatively close together to move increasingly farther apart. As a result, the light emitted from these objects has taken longer to reach us, making the universe appear much larger than its age might suggest. The universe remains an enormous and captivating expanse, with countless mysteries yet to be uncovered. Thanks to advanced technology, like NASA's James Webb Space Telescope, JWST, and other instruments, scientists continue to uncover new insights into the structure, composition, and history of the universe. These tools also help investigate various cosmic phenomena. Join us as we explore an immense cosmic structure recently detected by one of these telescopes at the far edges of the known universe. If you're interested in staying updated on such discoveries, consider subscribing to our channel, liking this video, and turning on notifications. One of the most intriguing questions in cosmology is, what lies beyond the observable universe? To reach those farthest cosmic frontiers, humanity would need to develop transportation methods that transcend space and time. Concepts like distortion engines or wormholes have been proposed. These ideas have been hotly debated in scientific circles. Some experts argue that such travel contradicts the principle that nothing can move faster than light, while others believe advanced technologies might eventually make it possible. The feasibility of faster-than-light travel and the development of technology beyond current human capabilities is still highly speculative. Even if theoretically possible, achieving such advancements would require machinery far more advanced than anything we can presently construct. According to the theory of cosmic inflation, the entire universe might be at least 1023 times larger than the observable universe, a scale so vast it defies human comprehension. Since we cannot see or measure what lies beyond the observable boundaries, we cannot confirm what exists outside. Nevertheless, by analyzing data from observable galaxies, scientists can develop theoretical models, and NASA plays a crucial role in that process. In collaboration with global space agencies and research institutions, NASA has made substantial contributions to our understanding of the universe. Even before the James Webb Telescope became operational, NASA released images of the ultra-deep field captured by the Hubble Space Telescope. When JWST launched and began observing, it focused on capturing images of the most distant galaxies ever detected. These observations unveiled countless galaxies shining in the ancient cosmos, appearing as they were millions of years after the Big Bang, about 13.8 billion years ago. Due to the universe's expansion, the light from these galaxies has been stretched to redder wavelengths, a phenomenon that enables JWST to detect them in the infrared spectrum. This capability allows scientists to observe galaxies forming in the universe's early developmental stages. The James Webb Telescope has observed various fields filled with distant galaxies, enabling researchers to study how quickly stars formed in the early universe. These observations have revealed a significant population of galaxies that were actively creating stars during that primordial era. These discoveries are not only fascinating, but also provoke deep philosophical questions. For centuries, humanity has wondered whether we are alone in the cosmos. The growing number of detected galaxies within the observable universe suggests that countless more may exist beyond it, an idea that is both astonishing and humbling. This brings us to the question, Are there extraterrestrial beings elsewhere in the universe? The possibility of life beyond Earth has become increasingly compelling. Numerous planets beyond our solar system, called exoplanets, have been discovered using methods like the transit method and the radial velocity method. Some of these exoplanets possess characteristics similar to Earth's and may potentially harbor life. This theory gained further support thanks to the James Webb Telescope's observations of the exoplanet WASP-96b. Located outside our solar system, this planet's light spectrum revealed the presence of water molecules, an extraordinary finding. Additionally, the spectrum showed indications of haze and clouds, features previously thought unlikely on a potentially habitable planet. Considering these discoveries and the existence of habitable environments beyond Earth, it becomes increasingly difficult to dismiss the possibility that intelligent life may exist elsewhere in the universe. While we have yet to obtain definitive proof, accumulating evidence suggests that extraterrestrial life remains a viable and enthralling possibility. Now let's delve into the concept of the multiverse in the context of the observable universe. The idea of a multiverse, also known as the many worlds interpretation, is a theoretical concept in both physics and philosophy. It proposes that multiple parallel universes or dimensions exist beyond our own. The multiverse is often discussed in relation to quantum physics, which studies the behavior of subatomic particles. According to some interpretations, merely observing a quantum system can cause it to collapse into a single state. In contrast, the many worlds interpretation suggests that observation causes the system to split into multiple realities, each representing a different outcome. It's important to acknowledge that the multiverse remains a highly speculative idea, currently unsupported by conclusive empirical evidence. As such, we cannot definitively determine whether it is a valid theory. Nonetheless, some scientists and philosophers find the multiverse concept intriguing and potentially helpful in explaining otherwise puzzling phenomena. Others remain skeptical, questioning the theory's scientific legitimacy. Given that we cannot yet determine what exists outside our universe, the multiverse remains a possibility, much like Schrödinger's cat or the enigmatic nature of dark matter. It's a concept that inspires both fascination and philosophical contemplation, though further research and evidence are necessary for confirmation. One related and equally mysterious phenomenon is known as dark flow. First proposed in 2008, dark flow refers to observations that some galaxy clusters appear to be moving faster than expected, based on our understanding of matter distribution in the universe. This led to the hypothesis that an unknown force, possibly dark matter or dark energy, might be pulling these galaxy clusters in a specific direction. However, the existence of dark flow remains controversial and has not been widely accepted by the scientific community. Some studies have suggested that dark flow is real and might be caused by a massive structure outside the observable universe, which exerts a gravitational pull on galaxy clusters. Yet other studies have failed to confirm its existence and instead propose alternative explanations, such as observational errors or limitations in data processing. While these conflicting studies point to the potential of a remarkable cosmic phenomenon, more research and data are needed to determine whether dark flow truly exists and, if so, what lies beyond the observable limits of our universe. What do you think about these mysteries? Let us know in the comments section. Don't forget to like this video and subscribe to our channel. Thank you for watching, and see you again soon.